everybody. As usual, questions are on screen for you there. Pause the video if you want to have a go yourself, or you can have a go along with me. See if you can do them quicker than me. That's a challenge for you. Well, not much challenge the way I waffle on, I suppose. So, I'll minimise that and I'll get started. So, 427.9 divided by 1. Okay. Now this is going to take us into a place value column that we haven't used before. Perhaps even a couple, but it's not an issue. You won't come across questions that need them in year 5, but you need to know that they're there. It doesn't just stop at thousands, it does carry on. You just don't need to know them as of yet. So let's get it set out. So you've got hundreds, tens, units, and then you've got tenths, hundreds, thousands, and then amazingly, really ingeniously, you've got 10,000s, and then 100,000s, and so on and so on. Okay, so you've got 427.9. You divide by 1,000, so everything's going to move 3 place value columns to the left. So you've got 1, 2, 3. So you're going to end up with 9, 7, 2. So you're going to end up with 0.4279. Okay, so that 9 that was in the tens has slipped into a brand new place value column for you. They're called the 10,000s. But I'm sure some of you already knew that was there. Okay, it's not just going to stop at thousands. It'll go on infinitely this way, and it goes on infinitely this way. Okay, it's just a case of when we introduce that column to you. So a bit of a cheeky one there, but the important thing to understand is that it still follows the same rules. Just because it's a new place value column doesn't mean that the rules have changed. It still follows the same rules that you've learned for years. 345 times 100. Oh no, sorry, 334.5 times 100. Okay, hundreds, tens, units, tenths. Might need a thousands, so I'm not sure. So you've got 34.5. Oops. Everything's going to move 2 place value columns to the left because I'm multiplying. So you've got 1, 2. So you're going to end up with 3, 4, 5, 0. Okay, 3,450 for question 2. Convert 0.3 into a fraction and a percentage. Okay, you've done this already. You've hopefully, as long as you did them, you were doing them with White Rose Hub Maths last week, I think. I'm all out of sync because I have to make these videos beforehand. You've done them at some point. So 0.3 into a fraction. Okay. So 0.3, you've got part of a whole. When you get to 1, you've got the whole. Okay, so that's the same as getting 10 out of 10 on your spellings, or it's the same as getting 100% on a test. Okay, so if you've got 0.3 out of 1, you could put that almost as a fraction. Doesn't make any sense, but you can put it. You can see you've got 0.3, and when you get to 1, you've got the whole. Okay, you've got 10 out of 10, you've got 100%. So the whole represents these, represents this. Okay, but 0.3 out of 1 doesn't make any sense. So we need to think of something that does, whilst these remain equivalent to one another. So if you multiply both of them by 10, you get 3 out of 10. Now, if you were to say that you got 3 out of 10 on your spellings, you consider that's obviously not a very good score, but you understand what it means. 0.3 out of 1 is a bit more abstract. 3 out of 10 suddenly is making sense. Let's multiply them again by 10. So now we've got 30 out of 100. Okay, 30 out of 100 again is the same as 3 out of 10. It's still not a very good score, to be honest with you. But now it's very easy. This one's easy, but this one's very easy to turn into a percentage, because each score is worth 1% now. So this, just pull it down, I'm making a big mess on the page now, I know. If 100 out of 100 is 100%, then 30 out of 100 will be 30%. Okay? So you've got all the answers on your screen there, or on my screen, not your screen. It's not yours. So once converted into a fraction, you can either do 3 out of 10 or 30 out of 100, and then it wants as a percentage, it's 30%. Okay? So it's all about understanding the correlation and the correlation and link between fractions, decimals, and percentages, being able to convert between. Okay, 0.3 is a nice easy one to give you on that one. I think they give you a hard one later on. No, they don't. Okay. 4256 times 3. Again, you do that however you want to. You can use a formal written method, but I'm just going to use an informal bit of jotting. 6 times 3 is 18. 5 times 3 is 15. So 52 times 3 is 6. So that's 600. 4 times 3 is 12. 12,000. Yeah, that's fine. Okay, 12,768. 12,768. Right? Yeah, perfect. Okay, and again, no difficulties in the adding up there. You can column add if you want to, but there's not any carrying to do. So it's fairly straightforward to do mentally. What is the value of 4 in 6,543,879? So you've got units, tens, hundreds, thousands, 10,000s, 100,000s, and millions. The commas in there, the commas in there make that so much easier to work with. It's the 10,000s column, but it says what is the value of 4. So it's not 10,000, and it's not 4. I don't know why you put 4. In all honesty, the value of the 4 is 40,000, or you can write it out. Did they spell it? Yeah. 40,000. I always spell 40 wrong. Try and put the U in it. 40,000. Okay, so that or that are your answer. Okay, if you put this 10,000, you need to read the question more carefully. It doesn't say what place value column. It says what value. Okay, really easy mistake to make. Really, it's one of those they always annoy me when you make that mistake, because you know what you mean. You've got it right. You know what you mean, but you just haven't given the answer in the way the question wants. They always wind me up, those ones. 1 3/8 times 2. Buzz off. 1 3/8 times 2. Easiest way to calculate these sorts of questions is to partition. So you're going to split it and do 1 times 2, which is, it's 2. Really difficult, that one. And then you're going to do 3/8 times 2. We've looked at multiplying fractions this year. If you have 3/8 of a cake, if you eat 3/8 of a cake, and then I go along and go, right, double it, have the same again. The amount of pieces that make a cake up aren't going to double as well. If I say to you, you've eaten 3/8 of my pizza, would you like another 3/8? Suddenly my pizza slices don't get smaller. I don't suddenly end up with 16 pieces. I wish. So I give some to you and then I end up with more. It doesn't work like that. So what I'm trying to say is that denominator doesn't change. If you multiply a fraction by a whole number, the denominator can't change. If you eat 3/8 of a pizza and then you eat another 3/8 of a pizza, it's still only 8 pieces to make a whole. So the denominator doesn't change, the numerator changes. So all you need to do is multiply the numerator by what you're multiplying by. Keep the denominator the same. So it's 6/8. So then you put it together, you've got 2 and 6/8. Does it talk about simplified? No. So that answer is fine, but you could also have 2 and 3/4, because you could divide both the top and the bottom of the fraction, the numerator and the denominator, by 2. Okay, either answer is fine. So either the one with the tick or the one with the tick. 26.8 minus 6.1. Okay, could have made that question a lot harder by playing about the place value columns, which they haven't done. I'm going to put it into column subtraction just because it's got that decimal point in. I just want to make sure I don't make a silly mistake. 6.1. It's actually lovely when you look at it. There's no exchanging there's no exchanging to do on there. So you would need to do 8 take away 1, which is obviously 0.8 take away 0.1, but it's 0.7. It's a lot easier just to say 7, isn't it? 6 take away 6 is 0. 2 take away nothing is 20. 2, 20, 20. Well, on the answer there, it just says 20, which is absolutely not right, because 8 take away, it is 20.7. Okay. 23,456 to the nearest. Oh, there's loads to do. Okay, to the nearest 10. Excuse the scruffy writing there. So to the nearest 10. That's 10's column there. Look to the one to the right, round it up. 23,450. Okay. 100, that's the 100 column there. Look to the right, 5, round up. 23,500. And 1,000, that's the 1,000 column there. Look at the one to the right, round down. 23,000. Just check I've got those right. 23,460. Whoops. That one there, isn't it? I've said it. I heard myself say it, round up, and then I didn't. So that 5 needs to be a 6. 23,460. There you go. I think that's the first mistake I've actually made with any of these. Yeah, there you go. And again, it's me just rushing on that one. I'm sure I'll check the video back, but I'm sure I said what I meant and then didn't write it. So silly it can be sometimes. 1/3 of 630. Try and redeem myself with this one. 630, and then it says a third. Okay, what it means is if 630, just in case you don't understand what the language of the question's asking you to do, if 630 is the whole, then it wants you to find what 1/3 would be. Okay, it wants to know how much this is worth. For me, it's dead straightforward what operation it wants me to do, but it might not be for you, so I thought I'd draw the picture. It wants you to divide by 3. It wants you to take 630 and it wants you to split it into those 3 equal groups so it knows what one is worth. Okay, so I'm just going to clear all that away because I don't need it. So the question's actually asking you to do 630 divided by 3. Looking at the question, you can see that's no issue at all because 6 is a multiple of 3 and 3 is obviously a multiple of 3. So it's using small numbers that are multiples. So it's going to be a really, really simple division. Okay, so 30 divided by 3 is 10. I can't do 0 divided by 3, but 30 I can. So I'm sort of using an equivalent of the bus stop method, but not needing to put it in, because I can just use my known facts. Okay, but again, if you needed bus stop method for that one, fair enough. I don't think that you do. I think it's much too easy to bother with even drawing the bus stop. You have to stay socially distanced on the buses anyway, I suppose, wouldn't you? 630 divided by 3, 600 divided by 3 is 200, so it's 210. Okay. And then finally, 8/5 subtract 2/10. Okay. Talked about this in class. These cannot, at the moment, interact with one another because they have different denominators. It's like comparing oranges and peaches. Who's got more? You've got 4 oranges and 3 peaches. Who's got more? It doesn't make any sense. Okay. Who's got more fruitiness? It doesn't work because they're different. So you need to convert. I don't know what I was going to say there. You need to convert the denominators so that they are the same. Okay. Now there's 2 options there. You can turn tenths into fifths, but this question works. Quite often it won't. So we don't normally do that. It's normally converting the lower digit denominator into a higher one. Now I was going to say the smaller denominator, but actually that's a bigger denominator because the equal parts that you need will be bigger. It's very boring and complicated, that. So if you get that, fair enough. If you don't, fair enough. What I'm saying is, normally you'd convert your fifths to tenths, not your tenths to fifths. Okay, normally that way around. Subtract 2/10. Okay, so I'll follow the layout that we've been doing this year. So we're going to pull both of them down. That one can stay as 2/10. Okay, but this one needs to change. So we're going to have to multiply both by 2. So fifths to tenths, you multiply by 2. But that means that 8 must be multiplied by 2 as well. Okay, which is 60. And they stay equivalent then. 8/5 is an improper fraction. Okay, it means I've got more than a whole. If I put 8/10, suddenly I haven't got a whole, so my amount has reduced. I went from having 1 and 2/5 to having 8/10, which isn't a whole at all. Okay, but 16/10, I've still got the whole and I've still got some left over. Did I say 3? I meant 3/5 left over, not 2. Whoops. Throw myself now, haven't I? Throw myself. 8/5 is not the same as 8/10. 8/5 is the same as 16/10. There you go. See, you talk long enough, you start confusing yourself. That's the issue. Right. 16/10 subtract 2/10. Not my best day today, has it been? Luckily, I've caught all the mistakes before putting it up, and you all going, "Oh, you got that wrong." 16/10 subtract 2/10 is 14. And then you can convert this back into fifths if you want to. It's 7/5 or 1 and 2/5 or 1 and 4/10. Okay, I wouldn't ever leave that as the answer because it's called improper for a reason. It's because it doesn't make sense. So you're never going to get a question wrong by converting an improper back into a mixed, if that makes sense. Okay, I would always do that. And again, if you put both as the answer, 14/10 or 1 and 4/10, then you're just securing yourself. Okay, in that answer. Right, I've waffled on a little bit, a lot today. As usual, I will put a challenge question on the screen for you now. Have a go, then I'll come back and I'll show you how I answered it and give you the answer. Okay. We've had a look at the challenge question that's been on the screen. Okay, I've got it at the top of my page here, but I haven't read through it myself, so I'll do so now and talk you through how I would solve it. So the sum of each side of the triangle is the same. What is the total of the two missing fractions? Okay, so it needs the answer to be in fractions. Right. Now what it's saying is this side will equal something. It might equal, say, we'll call it A. Okay, it will equal A. These three will also equal A, and these three will also equal A. So the most important thing, first of all, is to work out what that A is. We need to work out what the total of each side is. We've got the 3 at the bottom given to us, so we're going to use those. All right. So we've got 7/100, we've got 0.6, and then we've got 33. Now, I can't add decimals to fractions, doesn't work, so I need to convert. Choices are I can convert both of the fractions into decimals, or I can convert the one decimal into a fraction. And it obviously makes more sense to convert the 1 because it's less work, and I like less work. But also, the answer needs to be in fractions. So if I convert everything to decimals, I'll have to convert it back at the end. So I won't do that because it's more work and I don't like the work. So I will convert 0.6 into a fraction and then I will go from there. So 0.6 as a fraction is 6/10, or it is 60 out of 100. 33 add 7 is 40, and 40 add 60 is 100. So A equals, not 40, I don't know why I've written that. A equals 100/100. 100% or 1. Okay, I'm just trying to make all of them equal 1, or 100/100. So I've got 0.4 at the top, which is the same as 40/100. Okay, so let's get rid of that now. Don't need it. So I now need to find what this box is and what this box is. Okay, so on this side you've got 47/100, and on this side you've got 73. 40, 56, 73. Okay, so 47/100, add the 3 to make it 50, 50, must be 53/100. Okay, 73, add the 7, gets you to 80, and then add that, so it's 27/100. I do know it's scruffy, but you give me a scrap of paper, that's how I would be working it out, okay, just so you can see through all my thought processes. Right, so am I done? The sum of each side of the triangle is the same. What is the total? Sorry, there's something upstairs there. What is the total of the two missing fractions? That wasn't me just thinking. But I do know what. What is the total? What is the total of the two missing fractions? So all I need to do is add them together. Okay, when you add, again, think about it as pizza. If you had 53 pieces of pizza out of 100, and then you had another 27 out of 100, the denominator stays the same because it's still 100 pieces to make one whole pizza. So 100 can go in the middle. There. Adding these, that's what I'm doing now. 53 out of 27. 3 out 7 is 10, 50, 60, 70, 80. 80. Excuse me. 80 over 100. So you can have, excuse me, sorry. You can have 80 over 100, you can have 80 over 10, you could have 4/5. You could have 20 out of 25, I suppose. How you got to those, I don't know. Because it doesn't say to simplify. So that, I think, will be the number that you land on. Okay? But like I said, if you land on something else, as long as it is equivalent to 80 over 100, so 4/5, 8/10, and so on, then you've still got the answer right. Okay? That is Wednesday at the moment, that filming. This will go up on Friday, which means have a nice weekend. Have a lovely weekend, get lots of rest, have lots of fun. I hope the weather's good, better than it has been some days this week. And I will see you Monday for loads more cool maths. See you.